All right, so we'll go over file prep for the digital fabrication module. Continuing on with our Gasworks example here, that is more or less similar to how we left it off in the previous tutorials. You'll see I've included a couple extra buildings and things, and that'll have a little more to do with our fourth module. But in any case, we're talking today about file preparation specifically for CNC milling. And the CNC milling, I would recommend that you work with your topography that you had created using Cloud Compare, Rhino, as well as the Landau Topo Kit. You likely have a bunch of different types of meshes at this point with some of the environmental analysis that you were doing. Just know that our mesh that we're going to work from is that simplified mesh that you were performing the environmental analysis on. Another thing worth mentioning is if you did download the trial version of RhinoCAM and installed it, you can't actually save the G code out of RhinoCAM. So what that means for you is you can use this to play around with the machinery and learn the process of setting up G code, but ultimately you're going to have to do it at the University of Washington's fabrication lab, specifically the one we have in the College of Built Environments. So just to keep that in mind as I go through this demo, because this is a demo version, and so I won't actually be able to save that G code that we're going to work towards. But even before that, let's just start. We'll back up a little bit in that we right now are drawing in feet, right? And we know if we check our distance, this is 205 feet, right? So we're drawing in one-to-one space. And when we want to do CNC milling, we're going to be using a scale model. So the very first thing that you're going to want to do, for one, is to sort of be happy, with your mesh once it's ready to go and you're certain that the mesh will be what you want to work from and you're not adding anything else. Your starting point will be essentially to create a kind of stock for yourself. And so what I would recommend here is just make a box. Now we're providing you with 6" by 6" by 2" thickness. If you have a material preference beyond that, you just have to source the material yourself, but certainly that bounding box then would change based on the size you would like to CNC mill. But our foam in this case, our XPS, so extruded polystyrene, essentially housing insulation, is going to be, like I mentioned, 6" by 6" and 2" in height. Just keep in mind, you can't see that, right? Because it's a very small box. Now I knew I drew it from this origin point, from this corner. So if I type ZS, this represents that piece of foam that's going to be sitting on your CNC bed. And so as you can see, you're going to need to scale your whole site down to fit into this area. The other thing worth mentioning is whether or not you intend to include your buildings. So at this point, what I would recommend in terms of things that you are scaling down, I would say you can go ahead and turn your vegetation off. Now you may be interested in starting to etch additional information in. Now you recall some of the additional GIS information that I had mentioned you may want to get, such as streets, which are derived from the street center line GIS data, building footprints, or even something like parcel data. And you may have other data sets, but this may be something you also want to scale down because you do have the option to engrave this information into your topography. Similarly, the extruded buildings, those are going to be somewhat difficult to CNC out, but we can play around with perhaps a drape function, which I would recommend in general anyway. And so I'll want to, for the purposes of this demo, scale down the buildings as well. So we're just highlighting all the information we want to scale down, knowing that, contours, our original mesh model, our point cloud, and in this case also the vegetation, we're fine leaving that, and we'll actually delete that information out a little bit later. So I've highlighted everything, just hitting Control and deselecting that extrusion where I know the little box is. You can see just up here if you're following along, one closed extrusion removed from selection, right? So I know I did actually remove it. And in essence, we're just trying to scale this all the way down into that bounding box for us, or what we would call in the sort of CNC world, this would be our stock, essentially. So you can go ahead, once you have everything selected, type scale, and I would recommend just choosing your endpoint of the box, and then maybe the endpoint of your mesh. And you'll just go ahead and scale this whole thing down. And you can do it a couple times, you know, if your screen is glitching a little like mine is. You can just snap it to somewhat close. So there you go. This will give you a sense of how much of this information can fit into the box. Now you may want to just hit Control-Shift and start to delete off your bounding, the faces, the top and bottom faces of your box. And this has more to do with just being able to see into this, because what you're essentially doing here is creating a kind of test fit, an assessment of how much of your site you want to have in the box. And the other thing I might just do, just for the moment, is group all this, just so I can deselect very easily and look at everything, because for me, for my eye, it's a little difficult with the yellow to just see what's really going on. So as I look into this box at the moment, worth mentioning also, this is, for the purposes of this assignment, you do not need to model this at a known scale, you know, 30 scale, 70 scale, whatever, 75, 100. This is just a best fit example, and the notion of scale does not matter for the purposes of this, especially because you're given a 6x6 by 2 inch block, which is what this represents. If you have questions about scale and scaling your model, if your studio instructors want the model to a certain scale, we can troubleshoot that one-on-one and discuss that a little more if the scale notion is confusing. So in any case, what I'm starting to see here is, you know, knowing that from this corner to this corner is 2 inches high, my whole site is not going to get me very much relief, right? You can see even this large mound ends up being probably a 1/16 of an inch or something. So I may opt to start to scale this back up a little bit and keep moving this. So essentially what I'm doing is choosing just an area on site. We can do a little more as well. And then deselecting. And it may be that for my site, maybe it is just the topography here, this mound that I'm looking to CNC mill, and not the whole site, because I don't have that much relief, let's say. What that does for me is it gives me a good base in terms of understanding the heights of these objects, as well as, you know, how much of the foam really is going to show topography and how much of it is not. So in this case, you know, it's still only about a 1/2 inch relief really that we're getting in this. The most of the foam is not going to be doing much more than that for us. Just check the distance on this. Distance, unit, model. And at this point, you know, we could actually just switch. Keep in mind that we're drawing in feet, so I would like to switch my units at this point to inches. And this is because RhinoCAM only operates in inches. Do I want to scale the model? Yes, I do. Everything's going to move around, right? So the stuff that we have deselected is still going to remain in the other origin, but that's fine. We're going to take this to a new drawing space anyway, once we've figured out our test fit. And so now I can just evaluate things a little bit easier, because we're really drawing at the inch fabrication scale now, as opposed to the larger site planning feet scale. And so once I have something that I'm happy with, if this is my topography, I have some buildings and things that we can demo. You may look for slight anomalies like this, where maybe it makes sense for you to just nudge the bounding box over ever so slightly. Now, similarly, I'm running into some issues on this side, and so there may be a nice middle ground around there, where, you know, we can likely include, I mean, these two, which might be good for us. Once you're happy with this area that you're going to be CNC milling for this project, what I would recommend is just doing a mesh trim and trimming out the remainder of your site. Similarly, what you can do, if you no longer have your curve information from this box, you can hit Control-Shift and just choose these corners and dupe, not border, but dupe edge and join. So now you have that curve information here. So you could, as you move over to your top view, zoom select, start to trim out additional information, such as this road, which, well, it's a road, but in this case, it's registered as parcel data. And so all of this other info, for the purposes of our digital fabrication model, we're not going to need anymore. So at this point, we can ungroup our information and start to delete out all the excess data. These can go, and this stuff can go. So now I have potentially some line work information for etching. We'll be able to discuss building footprint etching versus draping over the building. But this will form the basis of our model. At this point, what I would recommend is moving all this information over to our to a new file, like essentially just saving this selected information, because this is primarily what we're going to want to work with. And we do have other stuff in this file, so you want to keep your digital fabrication file clean. I'd go ahead and grab this even just to start and hit enter, M for move, pick an endpoint and move this to our origin, 0, 0, 0. Zoom select to get back to it. And so now we have this information at the origin. At this point, I would highlight this file and we'll do export selected. And we'll save that. In this case, this is our third module, LR 441, CNC. Rhino 7 is fine. And so I'll just quickly hit pause on this just to get out of this file and open up the next file, since this is our original working file still from assignment 1. And you want to be careful here as you save out, not to save this version, right? You want to keep your assignment 1 data as it is. So make sure you hit no on this. So from there, we can go to our assignment 3 folder, just over my other window, but here. When you double click on it, we're going to want to run the CAM demo. And we're going to want to mill. One other thing that we should talk about in the context of this model, now that we're drawing in units, inches, is we're all good, right? So just first thing to really check for yourself is that you are drawing in inches. Zoom extents. Make sure you're at the origin. Everything's lined up very nicely here at the moment. The only other thing you're going to want to play around with very likely is the drape function. And we can try it out with the auto spacing 5. That's 5 units. You'll see what I mean as I drape over all this info. Let's go to our 3D view. And I'm just going to pull this over just so you can see what I'm doing there. So this becomes our drape model information. Looks pretty good, right? Now this would be in case you want to mill out the tops of the buildings. We can test this version to test for collisions. Sometimes milling buildings like this, depending on how much room there is in between them, there may be big collisions that could cause us an issue, but we could try with this model. Now, likely what you'll notice is this sort of drapes off along to the side, right? So you may want to create a cutting surface for yourself, or even just move this slightly beyond the distance. So you can see right now I've selected the surface. Another way maybe to do this would be to add a new layer and call this drape topo. Something that lets you know that this is your draped topography. There we are. And we'll just give it a different color just so we can see that the distinction between these a little clearer. There we go. So we could take all of our information, except for our stock, which I'll hit Control on, and just scale this up ever so slightly. Hopefully it's somewhat clear what I'm doing here. This is just to get us a little bit of additional edge information so that we don't have this draped information along the edge. The test fit may be tricky just in that, like this example, there's buildings really close to either side, but again, I could just select everything and just deselect that bounding box or that stalk, that representation of a stalk. And I'm just moving this ever so slightly. Might be that we don't, for this example, have like a perfect match for these buildings. So this will end up being kind of a topography on the edge, which might be interesting for the purposes of the demo for us to explore. So you're going to kind of do the same thing, just select your drape topo. At this point, this is what we're trying to work with. And our simplified mesh. Oh, sorry, I got the bounding box on that too. Call it stock. So that's just this. So now when I turn that off, we can keep our stock. So in this case, you're just taking these two, typing trim, and I'm just hitting enter to finish that. So now I've trimmed out some of that stranger geometry that comes as part of the drape function. Just know that if you weren't necessarily happy with your drape in terms of the resolution, like if I turn my buildings off, you may get strange things like this happening. Using buildings in general is going to be somewhat hit or miss. You may get some other weird things happening. So I'm just trying to show that as one method you could play around with. I'm going to go ahead and do a second drape without the buildings to demo from first. So I'm just turning here drape topo buildings, and I'm just turning that off because I also want to make a drape topo in general, and this will be with no buildings. Might just make that a darker green for myself. And what I'm going to show you here with this function is different kind of a recommendation, which will be if I select my drape topo here, and I'll say, I'm just going to turn the stock off. I can see the stock here at the boundary. We'll say drape. Now, you might recall I was saying the spacing for this was 5. You could try to make this more accurate. The denser the spacing is, in this case 1 unit is the most accurate we can make it. You'll see this will be nearly black because of how tight the spacing is. So the denser the information, the more difficult to compute though. So there's a kind of push and pull on this that you do need to be aware of. But I'm going to demo the 1 just so you can see what that's like. Now, I don't want this to fall off of my drawing edge, so I may just pick like fairly close here, but not beyond the object. So there we are. And to there is fine. And so that's just it won't be black in this case, right? Because I'm drawing in dark green. But what you're going to see, and I'll just move it to the side just so you can compare the two. Very, very laggy. So I would not recommend the spacing of 1 unit. In this case, inch, because we're drawing an inch. And you can see very laggy, very dense. In many ways, again, too accurate. You do need some room for abstraction, right? So this is not looking great. So just a word of advice that if you are sort of trying to make your model hyper accurate and you're trying to do this kind of operation, in this case, our original mesh is likely going to have a higher chance of success than our very dense surface, even though surfaces do operate better in general for CNC milling. So we'll go back, we'll do the drape. I just wanted to kind of show you that. Just know if it's laggy for you, you can restart, right? Like in the sense that just delete it and try again. But if it's lagging for your computer, it'll also be just a ton of information for the CNC milling operation to translate in the G code. So I hopped back to 5. I felt personally like 5 was real nice. Let's see what that looks like. Surface, and I'll just pull this to the side so we can evaluate it. Looks pretty good, right? Can also turn rendered on. Again, I don't recommend drafting in rendered. You're not going to have a lot of success drafting like this. I've seen that as a kind of trend. Very difficult to do, so just try to get used to drafting in shaded. And so our drape topo is the one that I'm going to want to work with. Now the stock is still here. Notice both are falling beyond this area, so I will want to just take my simplified mesh, turn that off, highlight these two, and type trim. And so I'm just trimming that up just to meet that 6" by 6" square boundary. So it all falls within that area, which is nice. And we're all lined up to the origin here. That's my 0, 0, 0. So we'll keep it at that for now. We can touch on engraving. So in this case, you know, these two parcel data sets that we may want to include as a kind of drop-off route, the road here, which you can read in the topo, and these buildings for the silos and things. And this will help you if you're making a kind of mixed media model to line these up later on, right? So you could do this just as well for the sort of center point of a tree or something like that as well. And so we'll go over engraving. But for now, I'm going to turn those off, that line work off. So that's my buildings line work, my parcel. And so we really are just working now with the draped topo, this here, and in some ways working with the stock. So at this point, we're completely happy with the model, the way we have it prepared, right? Where we have our topography here. We have this box that represents our stock, as well as some additional information that we may want to test just for the purposes of this demo. So that drape with the topo, I'm going to keep that off for now. We can also, we'll play around a little bit with the building line work as well as the parcel line work a little bit later on, but just make sure you keep all that stuff off. At the moment, we want to just work with our main topography, and for now we can keep the stock box on, and we'll turn that off in a moment. So at this point, we're going to start working with RhinoCAM. Now keep in mind, like I've mentioned, I'm using the demo, and I'm not actually going to be able to export the G code. Additionally, I don't have any of the tools, you know, in terms of bits loaded onto my machine, but I want to just kind of go through this just to give you a sense of the operations and some ways to, you know, do the simulations and different settings and things like that. But you will have to program this in the actual fabrication lab at the college. So what maybe I didn't underscore there is I started moving this over slightly just to start to show these tools over here. So you can see there's machining, post, setup, stock, align, material, and your machining operations, which is where most of the work really happens, I would say. The very first things you'll do in the actual lab, you know, is make sure you're on the right machine. We will be operating with a 3-axis machine. So for the purposes of this demo, I'm just going to hit OK. This is just a sort of standard setting. And then similarly, when you were in the lab, the post, you're going to want to set this up. And so here you can select post. Now, we're not going to have the post selected here, but essentially, you know, there's if you go programmable, I believe on our school's machines, it may be one of these two, but in any case, you'll get a kind of drop down, and specifically what you're going to be looking for is a post processor. It's going to be bracket UWABS, and then you're going to either choose small or large, and that value, which again, it won't be loaded onto here, but what you'll do is that value, the differentiation between the small and the large, just means if you're going to be using the small milling bed or the large milling bed. Just know that we have two, and so the small one is 1 foot by 2 feet. Both are going to have a kind of 6-inch max clearance. You know, 2 to 4 inches is really great. 6, you're really pushing it, and you'd want to chat with the fab lab about that in terms of depth. Most of you will be working on the small one, I would assume, seeing as we're demoing here a 6-inch by 6-inch by 2 inches block of foam, but you just know the larger bed is 4 feet by 8 feet. So that is where you would select your post processor. Now I'm going to keep mine just off here and hit OK. But that's just once this is the sort of motion you'll go through, you know, working from the top down, left to right, top down, as you're setting things up. So the next thing we would want to do, I would say, is select our stock. Box stock is fine. And you'll see because we have our stock on here, it's able to understand that that represents essentially our model bounding box. So just the fact that that's the exterior boundary of our shape that dictates this 6" by 6" by 2" because those are the largest parameters within the model. Now, if I was to have my buildings on and like building line work on, or even my 3D buildings, and they were floating above this model, it would read a higher height, right? Or if I had line work that was extending beyond the extents of this 6 by 6 block, then these values would change. So that's why we're keeping just these two parameters on at the moment. And we can just orbit around, make sure there's nothing sticking out, which there shouldn't be. And we'll hit OK. So at this point, you're welcome to turn the stock off. And so I just hit the little button there to make sure that that's off. And so at this point, the machine knows that that represents our piece of foam. And the next thing we want to do is align. So I'm just clicking here on the sides to get additional drop downs. So we'll align the stock. And what we want to do more than anything is align the stock to the top. You can play around a little bit with the other, this is centered, you know, northwest. A lot of this isn't going to really matter for us because the object we're milling is flush, right? But what does matter are these values, the Z alignment. Now, aesthetically, you may be thinking, oh, well, I don't want this large of a base for my, like this would be a lot of foam showing, right? But just know that you could take this and cut this in different ways. So just for you to play around with, I'll show you how to calculate milling time, but good practice is just to keep it right at the top so the bit doesn't have to remove materials, and rather we can just manually cut the bottom later in the wood shop or something like that. So alignment top, and these are essentially negligible for how we're doing this operation, which is everything is flush to our stock. So, okay. A material, again, is going to be something that you're going to want to set in the lab, but just to give you a sense of what this looks like, lots of different materials here, you know, woods and steels, all the stuff you can mill. My demo preset seems to be plastic ABS, so I'm just going to stick with that for the purposes of this demo, again, because I'm not actually set up to a CNC machine on this. The next and likely most important step is really the machining operations, and this is where you have a lot of control over how you want to essentially mill this. So we're going to work with the 3-axis to begin, because the first thing we want to do is remove this material to get the topography to show up, right? Afterwards, I'll show you how to do some engraving, but the first operation really is to remove that first material. So machining, 3-axis advanced, and you'll see there's a lot of different options here for finishing and rough passes, for instance. Because we're working with foam, we can just go ahead and do a finishing pass right away. We don't have to do a rough pass like the way you would with wood. So essentially here we have a couple different ones that you could choose from. So parallel finish, very standard. This will mean, and you'll see this in the simulation later, but this will mean that the bit moves left to right, or east to west, or however you want to think about that, in a kind of linear motion, like a kind of lawnmower pattern, if you will. We have some other options. We know we can do spiral machining, so this will create, it'll sort of spiral from a known point and mill it out that way, and you can set that point. Similarly, you can also do a radial machining, so you could set something from, like, instead of a center point, you could pick an end point, and everything would radiate out from one set point. So depending on what you're trying to say with your model, what you're trying to communicate, those could be different methods you want to play around with, or even just test for yourself in the context of this module. But I'm going to show the parallel finish as a kind of standard finishing method. Here you can see more clearly, I guess, what I was trying to describe in terms of that pattern, how the bit moves. And so this is where you'll really set all your finishes. Now, again, the first thing I would say really is you're going to want to select your tool bits. Now, I don't have any loaded, so I'm just going to create some. This right here is a ball mill, and so this is kind of nice that we have this as our demo in some ways, because the ball mill is something you would use for actual finishing. And so this will line up in this case for our finishing pass really nice, as opposed to maybe like a flat bit, right? So this is rounded. And so you'll get a nicer kind of resolution with this. The only thing I'm going to change here is I do know that so we could do a 1/2 inch. Now, if you do a 1/2 inch tool ball bit, well, you do a 1/2 inch flat bit generally for like a rough pass, at least for what we have in the lab. But here, I know we have a 1/4 inch as well. So you could do, in this case, a 1/4 inch ball bit for a finishing pass. And you can see over here how that size changed. And so for the purposes of this demo, like I'm just essentially making up a bit. And so I'll just save that as a new tool and exit out of that. To select this, it's a little strange, a little bit of a glitch in my opinion. You have to pick your tool first. So you go to the text and then drop down. And this means it's selected. But that's the only way you can really select it. So just kind of be aware of that, because that'll essentially affect if you're able to generate this or not, is you actually do have to have a tool selected. So be sure of that. This is a great place to start, in my opinion, is setting that tool. Feeds and speeds, the lab is going to have set parameters that correlate to the tool. And if not, they do have, I'm certain, a sweet spot for how these materials should be, or how these parameters should be set, especially dependent on a material. The other thing the lab would like is for us to override the max clearance. So this will be this plane, how far above the bit will move as it sort of slides side to side. And so we have a 1/4 inch, they prefer an inch clearance. So good practice just to avoid any collisions just in case. So just override that there. So we've gone through clearance plane, feeds and speeds. We set our tool right at the start. Control geometry we don't need to work with just yet. This is where we're going to do our engraving later. Let me just go to really the other, I would say, most important part here is in the cut parameters, as you can see here, and you're looking at the step over control. And so this seems to be, at least in this demo version, set at 25, which is not bad. Essentially, as you increase this value, this is just the amount this is kind of diagrammed somewhat nicely here, where it's the amount the tool bit will overlap with itself of the tool diameter. So 10% overlap, but the cut time will also increase. So maybe for the start, I'll show you 25, which 25 is the kind of standard default on this. And we'll start with that. I'll show you what that means in terms of our cut time, because we can calculate that. And then we can go back and play around a bit with this value and look at what that means for precision. So at the moment, we're pretty much good for the purposes of this demo. So I'll just hit generate. And so now you can see the machining passes here. It's looking pretty good. If we want to be certain, we can right click on this and simulate. And there we go. So as you look at it, you can start to see these grooves. And if you're not sort of happy with that finish, you can go back and right click and edit. And again, I would go to the cut parameters. And so like now we can see, for instance, or actually, let me back up for a second. You could look at your information. So right click information. So this is just for the purposes of starting to calculate the machining time, the estimate here, machining time. So we're looking at 40 minutes for this cut. Hit OK on that. Now, if I want to up my precision, I can right click and edit, cut parameters. And let's see what it does for us for 10. Generate. So you can see the step over has increased, right? There's far more lines. Now we can go ahead and right click, simulate. And even the demo, even though it's operates far quicker, we can start to get a fairly good sense of, you know, the resolution is a lot higher. And it's taking a lot more time. So once we're done with that, we can take another look here at our information. and you can see another hour has been added to the machining time, right? So as you increase that value, the percentage, which seems potentially counterintuitive in some ways to my mind, but the lower the percentage, the higher the overlap. So the more time it will take, the more passes the machine will do. So just be aware of that. And, you're able to just sort of sit by the machine. You don't actually have to do much. So you could be doing work while the machine's operating, which is kind of the nice part, I suppose. So that's just what that looks like. And that has everything to do with just your finish and what you're wanting to do. The other thing you're gonna want to play around with here, potentially at least, is if you have things like your buildings information, or you have parcels and all this other stuff, you may want to etch things in, right? Let me just go back to my setup, do another, this simulate thing will be up here, and just know that you can kind of toggle between these two things, right? So if you're in the simulate setting and you're turning on additional information, it's not going to appear. So just know that you have to go up here and hit program. And so now you can see that additional information, right? If we want to engrave this line work for a number of reasons, and we can talk about those while we do it, but if we want to do that, we're going to have to go to our machining operations. And in this case, you're going to go under your 2-axis, and specifically you're looking for engraving. So that's right here. And what's really nice is right away it does prompt you to go to your control geometry. Now the control geometry will be this, but we want this projected to our surface. So just a word of caution, don't project it onto the same layer. In this case, I can just project it all to parcels. That's totally fine in my opinion for the purposes of this. We're going to type project. And from here, you could also switch this if you wanted to. So right now, the output layer will be the current layer, but it could be the target object, which we certainly don't want, or it could be the input. In any case, you'll select your target, hit enter, and now you have that line work projected onto your surface. I'm going to go ahead and just delete this data because I'm only concerned with this data here. That's what I want it to engrave. So over here, you can select curve and edge regions. So we're going to click that, brings us back over here, and it says select object. Now we know those are the only curves in this drawing space, so I can actually just type cell curve to select all those curves and hit enter. And you can see all those are now loaded into this parts region. Those are all individual parts. Depending on what you're doing, you may want to edit your bit, and this will have to do with the lab, and if there's an appetite to change a bit for this, or if they believe you should just keep going with, in this case, this 1/4 inch ball bit. I'm not sure if they even have anything more fine than that, but of course the finer the better if you're trying to have just a delicate line, and you'll see what I mean, because I'm just going to keep this, but in theory, if you made an additional like ball mill 2 and you had something that was a finer diameter here, so if you look at that and we have it at like 1, something even thinner could potentially get you a nicer finish, but I'll just stick with ball mill 1. So again, just make sure you have that selected. The other thing to play around with here is the cut parameters. So you do need a total cut depth in this case. I would start at 0.1 and kind of go from there. Just run the simulation and see what you think. And the only other thing you can kind of play around with here is just, like if it follows like along a path, along the line, these kinds of things. But let's just hit generate and see what we get. And so this will show you how that tooling path happens. Now, the one other thing is, because I did the engraving afterwards, it goes to the top. Now we're going to want to run that on the bottom, because we want to do the parallel finishing first, and then we want the engraving to come in. So I'd recommend just click down and pull that below. And now you can run a full simulation. So knowing full well, just this is going to take 1 hour and 40 minutes, given that 10% overlap. and there's that engraving. So as you can see, pretty thick, right? And so this is why I was recommending potentially you would want some sort of thinner bit. Now, this is knowing that this is essentially 2 inches in height that we're talking about and 6 by 6. So it's a very small thing we're machining. Normally the 1/4 inch may look quite nice for a large wood CNC model, but if you can get a finer bit installed for this second engraving, then I would say clearly that would be better. But hopefully you can see how this could be valuable. Right now this looks sort of, I would say, crude, but especially if you're thinking more about just building locations and things, if you're making a kind of mixed media model, you may want to do something like this, right? Where you have these cues essentially in terms of like where to put buildings in afterwards, or even center points for trees, something like that. So we can go back to our program, and maybe just to close out this part of the demo, what you're going to want to do once you're done is right click and post. Now I'm not going to be able to do this, right? Cannot post while running in demo mode. So that is how you would export your G code, which is what the CNC uses. So just know that's the method there. Right click, post. Just for the purposes of this demo, what I might want to do now is I'm just gonna switch things up, and I'm gonna just show you if we're machining this operation. So I might just cut those, and we'll do a different setup now with this, because we can play around a little bit with the buildings, and I might just do a different kind of machining pass just for you to see what that's like. But I do want to show, you know, how this resolution is going to change for you, and you can kind of debate with yourselves if you know, including building footprints in the drape or building massings in the drape is really a good method, especially at this scale. But we still have our stock selected, so I believe I can just go ahead and let's see if I can just jump the gun here and go right to, let's say, like a spiral machining. And all these are still set, which is nice. And then let me just check my cut parameters. There we are. So let's just do this also at 10, generate. Let's see what we get. Oh, there we go. So that's loaded. I just had to think a little more longer than I would have imagined. Let's just take a look at the simulate. Okay, nice. So that's just to give you a sense of, you know, this is a very legible, although at times can be very nice, kind of spiral. So depending on your model, you could do something like that as well. But just to give you a sense of how that building finish might end up looking. In this case, if you tested that and you're not happy with it, you know, you can just, I tend to just hit cut, although maybe you can hit the delete key, I'm not sure. There's radial as well, and but I'm curious just to see what the parallel finish will get us as we kind of increase parameter, just to see potentially how nice we can get the buildings, or at least to what degree. As you can see here, some of these aren't even being registered, and that's likely just because of that trim function, and it broke those geometries. But let's see, well, simulate first, and then we can take a look at the cut time with the added buildings, if that impacts it or not. But in any case, the demo more or less is over. This is just to kind of show you what the implications are of trying to mill out building footprints, building massings that you've draped over top of. So at larger scale models, this totally works fine, but maybe if you only have a couple buildings, you know, it's not necessarily that great, but it really depends on your own kind of narrative and purposes for the model itself. So hopefully that's kind of helpful, just to give you a sense of what you're in for with that kind of finishing. So again, I'll wrap up the tutorial here and just say that, you know, what you end up wanting to do is right click and get your post out. I can't, just because I'm doing this on a demo on my machine here. So one thing I just really quickly that I didn't touch on is you'll have to just talk with the lab tech in terms of if you want the full setup posted like I just did, or previously when we had the engraving here, you'll notice I actually did it from the individual so that there's essentially 2 passes you can load, and that would be done for separating the bit. So because that bit manually needs to be changed out. All right, so yeah, I think we can leave it at that.